So, hello everyone again. This is 6th lecture part 2 of electromagnetic induction. I am Sameer Lavankar. So, let us begin our lectures. So, in the last lecture we concluded the inductance concept, and in this lecture we will start with AC generators. What are these AC generators? What are the applications of AC generators, and so on. So, let us move on to the beautiful concept of AC generators. So, this person right here is involved with AC generators. He is Nikola Tesla. So, let us move on to what is this AC generators. Please look over here, please concentrate here a little more. So, the phenomena of electromagnetic induction has been technologically exploited in many ways. These exploitations are in many ways, like it can be in terms of AC generators, it can be in terms of AC generators, it can be in terms of transformers, it can be in terms of applications of eddy currents, applications of eddy currents, then moving on to what were the applications of eddy currents? Applications were like furnace, electrical furnace was being used, then used in brake system in rails, brakes in rails, and so on. So, these are many ways in which it was technically exploited. What was exploited? Exploited as in using it in complete sense, using its applicability in complete sense. So, the phenomena of electromagnetic induction has been technologically exploited in many ways. An exceptionally important application is the generation of alternating currents. So, alternating currents is the next chapter after electromagnetic induction. So, alternating currents was the generation of alternating currents. So, everything which comes as a part of electricity in our homes, in our offices, in our day to day, every electricity concept is always involved in AC supply only. So, from where who is the father of this AC? Father of AC is nothing but electromagnetic induction. Due to electromagnetic induction, today we have AC, that is alternating current. So, an exceptionally important application is the generation of alternating currents, that is AC. The modern AC generator. So, what does AC generator means? It generates AC. AC is alternating current. So, a device which is used to generate electricity, a device which is used to generate current. Which type of current? There are two types of current typically. One is direct current, that is DC, and one is alternating current, that is AC. So, a modern AC generator with a typical output capacity. What does output capacity means? That this is the value which it can sustain once, it can evolve once, it can produce this much. So, a modern AC generator with a typical output capacity of 100 megawatts is a highly evolved machine. So, that is, there is a maximum thing right now which is one of the technologically exploited application of electromagnetic induction. So, who invented this? Who was responsible for this? So, this gentleman here in right side, that is Nikola Tesla, the Yugoslav inventor Nikola Tesla is credited with the development of this machine. Now, the principles involved, we will talk about the principles involved and the methods which are involved in calculating or producing an alternating generator, AC generator. So, one method to induce an EMF. What is EMF? EMF is nothing but voltage value. So, one method to induce an EMF or current in a loop is through a change in the loop's orientation. Change in the loop's orientation is as in if the loop is like this, if we change the value of A, then the area between B and A gets changed. Let us say the B is acting in this, let for an example, okay, let us say the B is acting in this position and the area is like this. If the area vector goes here, then the value of theta is 0, and hence the value of flux at that particular time is different. Now, if the orientation of this loop gets changed, then the value of area will be like this, but B will always act in this position, but the cos theta value has changed, and hence the value of flux at that particular instant has changed. So, now let us move on to this thing, that if the value of B is always like this, and let me use this. So, let us say the B is always like this, and the value of A, if we keep on changing the loop either like this or completely in a rotational form, then the value of the theta involved will get changed. if the value of theta involved get changed, then the flux at a particular instant in any form of time will get changed, and hence d phi by dt will not be 0. If d phi by dt is not 0, then the EMF will be produced, and as EMF is produced, there will be a voltage difference, and then hence there will be production of current, and hence current is involved, and hence current is generated. As current is generated, as EMF is produced, and that is the only and only principle or concept involved in AC generators. Due to this orientation change, there will be a production in current. So, one method to induce an EMF or current in a loop is through a change in the loop's orientation or a change in its effective area. So, either you can change the loop direction like this, or either you can increase or decrease the area. It depends on your way of calculating or producing current. So, this concept is again done. I will reiterate it again. So, one method to induce an EMF or current in a loop is through a change in the loop's orientation or a change in its effective area. So, now what is the principle involved for operation of a simple AC generator? So, the principle of operation of a simple AC generator is as follows. As the coil rotates in a magnetic field B is involved, the effective area of the loop, let us say the effective area is nothing but A dash. If the complete area is A and A dash is the effective area we are talking about, then that value is nothing but, see, please understand this line, that is the effective area of the loop, that is the phase perpendicular to the field. The phase perpendicular to the field is A cos theta. So, this value is nothing but A cos theta, where theta is the angle between A and B. So, an AC generator converts mechanical energy into electrical energy. So, first of all, the principle involved is nothing but this only, that if the value of B is acting like this, and if the value of A is here, if the value of A is like this, if the loop is being kept like this and the value of B is here, then the area vector will be perpendicular to the field, will be perpendicular to the area. So, it will be like this. So, both are acting like this. So, the effective area is nothing but A into cos 0, which is A. But if I move the loop, let us say in 90-degree position, then the value of A and this will be, so the value of B and A will be at an angle of 90, and hence cos 90 is 0, therefore, there is no flux. There is no flux, but if it is at a different position, let us say it is like this, the area is like this, then the value of, then the direction of area vector will be like this. Let us say it is 45 degree, then there will be a value of cos theta, which is 1 by root 2, and hence you will get a different value of B. We will get a different value of flux. So, this is the only principle involved. With the rotation, with the change in the loopage, there will be a production of current. So, and now different concluding point of this slide is that an AC generator converts mechanical energy. So, this movement is mechanical, and what it gets converted into is electrical energy, which is passed through a circuit. So, an AC generator converts mechanical energy into electrical energy. So, this is the final thing, this is the final application of the complete concept we were talking in the last 5 lectures. So, this is the final funda, this is the final thing which we need to go up, that wow, what is the application of electromagnetic induction? We learnt, okay, that anything is coming towards some other neighboring thing and you are getting an EMF induced. So, what is the production, what is the application? So, this is the final application. Anything which you are getting in your home is only and only possible because of this invention. So, please look over this invention very nicely. So, please look over here. So, the basic elements of an AC generator are shown in the figure. So, what are things are written here? Let me explain to you. So, axle is nothing but a virtual or an pseudo line through which any coil or any loop or any let us say solenoid is revolved around. So, that is known as axle. So, this is the axle here, which is dotted line. Coil has already been talked to you in the first lecture. In every lecture, coil has been talked to you about. Alternating EMF. What does alternating EMF mean? That the EMF is not constant. Either it can be a sinusoidal wave, or it can be a wavy pattern, or it can be uniform. So, it will not go back, let us say like this, it may go like this, like this. So, alternating EMF. So, EMF is varying with time. Carbon brushes, a little bit about carbon brushes and slip rings is in the subsequent slides. I tried to make it I tried to make this diagram very clear, so that you know and you understand each and everything written here. So, little bit about, please make sure, please have patience, I will understand you what are slip rings and carbon brushes in the subsequent slides. So, for now just understand that these are slip rings, these are slip rings. The name suggests you something, it is slip, using for slipping something, and rings is in the form of ring. Carbon brushes, something will be made of carbon, and brushes as in it is used to brush something, brushing. So, let us move on here to the things written towards your left. So, the basic elements of an AC generator are shown in the figure. It consists of a coil mounted on a rotor shaft. So, this is the coil on which it is mounted as in placed. So, anything which is mounted on something, let us say what we say, that a clock is mounted on a ceiling, sorry, on a wall. So, we took a clock, we mounted it on a wall. So, similarly, what it does is a coil is mounted on a rotor shaft. What is a rotor shaft? Any machine, any motor which is used for rotating. Rotor is related to rotating, and shaft is any machine. So, it consists of a coil mounted on a rotor shaft. Next, the axis of rotation we are talking about. The axis of rotation of the coil is perpendicular to the direction of the magnetic field. So, axis of rotation is like this. Please make sure, please look at the diagram and please look at me. So, the axis of rotation is like this, going like this, and it is perpendicular. What does perpendicular means? For easy mathematical terms, let us understand that the theta between the magnetic field and the value of axis we are talking about is 90 degree. The direction of magnetic field, whenever two magnets are being kept like this, the magnetic fields between them goes in this way. So, these are the magnetic fields we are talking about. These are the magnetic fields we are talking about. So, here this is the direction of the magnetic field, and this was the axis I was already talking to you. So, please make sure what is the angle here, the angle is 90 degree, and hence it is perpendicular. So, moving on, it consists of a coil mounted on a rotor shaft. I explained to you very nicely what is the thing written here. The axis of rotation of the coil is perpendicular to the direction of the magnetic field. So, this line is also being understood, told nicely. Let us move on to next line. The coil called as armature, please. So, this is just a concept or new term involved, that the coil is also called as armature. So, the coil called armature is mechanically rotated, please make sure it is mechanically rotated, and that is why the concept written here was that AC generator converts mechanical energy into electrical energy. So, what we are doing is we are using some mechanical force to rotate this coil. So, the coil called armature is mechanically rotated in the uniform magnetic field. What does uniform magnetic field means? Uniform magnetic field means in the area in which the magnets are being evolved, at that point dB, that is change in magnetic field with time, is 0, and change in magnetic field with space is also 0. So, hence it is uniform, magnetic field does not vary. The coil called armature is mechanically rotated in the uniform magnetic field by some external means as in some direct force, like let us say for a very simple thing, either you can also rotate. If you are rotating, then also it is some external means only. If you are using some gears, you are using a small gear, then a big gear, and then a very big gear to rotate it, then also it is a mechanical by external means only, and it is mechanical concept only involved. So, the coil called armature is mechanically rotated in the uniform magnetic field by some external means. The rotation of the coil, please look over this line very carefully. So, the rotation of the coil causes the magnetic flux through it to change, and so an EMF is induced in the coil. So, very basic concept, very basic EMF concept is being used. What does Faraday's laws of induction states? Faraday's laws of induction states that EMF produced is nothing but minus n d phi b by dt, that is change in flux with respect to time, or the time rate of change of flux leads to a production in EMF. Now, how will EMF change? Let us say t is equal to 0. Let us say at t is equal to 0, the magnetic field is like this, the area involved is like this, the value of theta is 0. Okay, let me change the direction for a quick. Let us say the magnets are being kept like this, one towards you, one from my side. So, the value of magnetic field is like this, the area is like this. Now, if the value of this is changed, the theta will get changed, and hence the EMF at any time t will change, and because there is a d phi by dt involved, and hence there will be production of EMF. So, nothing but a basic principle of this concept is being involved. So, the ends of the coil are connected to an external circuit by means of, sorry, please I will iterate this line again. So, the rotation of the coil causes a magnetic flux is nothing but phi b value, magnetic flux through it to change, and so an EMF is induced in the coil. So, an EMF is induced, EMF is nothing but epsilon value. So, this is the concept in the third point. Next line, the ends of the coil. So, these were the ends of the coil, this and this are the ends of the coil, or only this is the end of the coil here. So, the ends of the coil are connected to an external circuit by means of slip rings and brushes. So, these are the slip rings involved, these are the carbon brushes involved. Let me first explain to you what are slip rings and carbon brushes, and then I will move on to the last line. So, for now the ends of the coil are connected to an external circuit by means of slip rings and brushes. What are these slip rings and brushes? Nothing to memorize here, just to explain everything, so that this complete figure is completed. That is why I am keeping you well versed with what are slip rings and carbon brushes. So, slip rings are electrical connections used to transfer power to and fro as in passage and receiving, passage also, going through also, and receiving also. So, slip rings are electrical connections used to transfer power to and fro from the rotor of an AC generator. What is a rotor? Rotor is an electric shaft we were talking about in the first point. So, slip rings are electrical connections used to transfer power to and fro from the rotor of an AC generator. They are typically designed to conduct the flow of current from a stationary device to a rotating one. So, it is nothing but a device, it is a device which is used to take power and give power, it is a power receiving and giving. So, this is the basic concept of slip rings. What are carbon brushes? It ensures spark free transmission. What is sparks? Like in sometimes you see that a spark is being evolved, a chit voice is evolved. So, that chit voice, just to reduce that chit voice, carbon brushes are being used. So, it ensures spark free transmission and reduces the damage of the motor. If the damage of the motor is being reduced, then the efficiency of the AC generator is more. Everybody know that there are leakages, anything is not ideal, but as a human being, as a person involved with production of current, I will try to maximize my motor, I will try to maximize my generator, and hence good quality carbon brushes are being used. So, it ensures spark free transmission and reduces the damage of the motor by carrying the current to and fro as in passage of current and receivance of current. So, this was slip rings and carbon brushes. So, for now these four concepts have been told to you very nicely. AC generator concept, little bit principle was been told to you very nicely. What was the principle involved? Principle was similar, only with the change in the value of area loop, there is a EMF produced, there is a change in flux, and hence there is an EMF produced, and this was a simple basic principle of AC generator. In the next slide, in the next lecture, I will start from this point here, that what is the concept involved, what are the value of exact mathematical terms being used to calculate AC generator concepts, the EMF produced, and then I will explain to you the applications of AC generators, followed by some problems, and that will be the end. So, for now, thank you.